about now? It says excellent connection, but yaxshi. Olti ming 800 bitrate ishlatishimiz kerak ekan streaming uchun. Ko'taramiz 6800. Olti ming 900 qilib qo'yaman. Okay. Hop. Now let's check our activity monitor. Right, the OBS is using a lot of space, but anyways. Aloqadami? Shu yerdami? So istirohatmi hammasi shunda? Muammo yo'qmi? O bo'lar ekan-ku, chiroyli stream qilsa ham, to'g'rimi? Hammasi joyida. So we are back again to use our freaking monitor. First off, I want to go to YouTube. No, not here. Alright, let's close this tab and go to YouTube. And I was learning algorithms and data structures, right? CS Dojo.
Hey YouTube!
Not this one.
Hey YouTube! Programming, and in particular using arrays. To understand that, let's take a look at this piece of code in C. This line int a equals 1. When you compile and execute this line, of course a variable called a is created and the integer 1 is assigned to that number. And this integer 1 is stored on memory and not on storage. And that means that when you turn off your computer after executing this code, this integer 1 will just disappear because everything on memory, of course, disappears when you turn off your computer. But how is this integer stored on memory exactly? For me to explain that, you'll need to understand two things. The first one is that each integer, when it's stored on a computer, it's often expressed as 32 ones and zeros. So for example, the number 1 can be expressed as a bunch of zeros and then 1 at the end. Actually, that's 31 zeros and then 1 at the end. And the number 2 can be expressed as a bunch of zeros and then 1 and then 0 again. That's actually 30 zeros, 1 and then 1 0. And just like that, pretty much any integer that you might encounter in real life, whether they're 100 or 200 or minus 223, each of them can be expressed as 32 ones and zeros. Now, each of these zeros and ones is called a bit. So a bit is either 1 or 0. So we say each integer can be expressed with 32 bits. And you don't have to worry about how it's converted exactly if you don't know about it yet, but just know that pretty much any integer within a reasonable range can be expressed with 32 bits or 32 ones and zeros. Okay, the second thing you'll need to understand is a simple model of memory. Memory can be thought of as a long tape of bytes. Now, what is a byte? A byte is basically a small unit of data, and it consists of 8 bits. So each byte might look like this, where it has 8 bits, or this one. Now you can visualize the simple model of memory, a long tape of bytes, like this. So this is the long tape, and each of these compartments represents each byte. So you can sort of imagine a bunch of bits, 8 bits to be exact, being crammed into each of these compartments. And then you can store bytes, which are of course small units of data, in these compartments to represent anything you want to represent on your computer. Now your computer needs a way to find any particular byte very easily, and you want to be able to do that because you want to be able to do things like store 2 bytes in these 2 compartments and then store 4 bytes right after that, and maybe retrieve 2 bytes from the first 2 compartments. And your computer achieves it by assigning an address to each byte, and each of those addresses is represented by a single integer. So in this hypothetical example, we have the address 120 for this byte and 121 for this byte, and so on. At this point, you might say, wait, why do we have these particular numbers, 120, 121, and so on, representing the addresses for these bytes? Well, the answer is, I came up with this arbitrary number, 120, to represent the starting address for these bytes. But in reality, you don't have to worry about it. And you don't have to worry about it because the operating system determines what the starting address will be for your particular application. So basically, the operating system, whether it's Mac or Windows, decides what your application should live over here in memory, and then someone else's application, let's say Google Chrome, should live over here, and so on. But the important thing to understand here is that even though the starting index 120 is arbitrary here, the way you have consecutive addresses, 120, 121, 122, and so on, that's exactly like a real system on your computer. Anyway, like I said earlier, each integer can be represented with 32 bits.
Alright, so he's saying that. Alright, let's open up a new tab. What is he saying? Like app eraser. Let's go to the application and start. We have to log in. Like, how do I log in here? Sign up or log in. Log in with Google. Let's use our freaking email. Right. Like, let's go to Golang tutorial, even though I'm not actually learning Golang, but here I can have a lot of space for that. So he's saying that any integer can be represented with as bits with 32 bits, right? Is he saying that? What he's saying? 30 bits for int. Yeah. So that means like we need to have 32 bits for an integer, for an int. And what he's saying is that memory a long tape of bytes. Alright. So basically we have this freaking memory here, right? Memory, and then we have a group. Is this correct? Right. let's make this a little bit beautiful. Oh shit, yeah. Oh shoot, sorry. Control C, Control V. Just gonna go there, here, here, and here, and here. Or you say here, we're gonna go. We're gonna move this a little bit further. Alright, here, 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 and right here, and here as well. So yeah, this is memory. Alright, this is memory. The memory is equal to, what was that? I forgot. It's a long tape of bytes. A long tape of bytes. So basically each column, I would say, is a byte. So byte, small unit of data. Exactly, because imagine that we have this 8 bits, 1 2 2, you know, just a reminder that bits are only considered of only zeros and 1, 0 and 1. So 1 0 0 0, like how many numbers how many bits? 1 2 3 4 5 6 0 1 0. Just to teach you, just remind you that here this is considered as 0. All right, 0 and 1. The first part is 1 2. All right, 4. Oh, sorry. I actually forgot, like, but let's remind ourselves, right? Bit representation of numbers. Let's see. I hate this, honestly. I cannot zoom in here. How do I zoom in? Oh yeah. So here we have decimal 0 0 0 1. Oh yeah. If the first value in bits is 1, then we consider this as 1. If it's the second, then 2, then 4. Here why it's 2? Because this is 1, this is 2, and here this is 4. Yeah, now I understand. I just remembered. I recalled everything. Here this is right here is 0, so you don't have to include that in our calculation. This number whole is equal to 2. Yeah, this number is equal to 2. So we can drop the first zeros, 1 2 3 4, then just make this as this. This bit representation is number 2. You see, this is correct, so I wasn't wrong. So now what did he say? Like 30 bits for an int, 32 bits for an int. A bit is equal to 1 or 0, exactly. So as I was saying, like a bit is equal to 1 or 0, so nothing else, just nothing else. Let's continue.
Sometimes, depending on the environment, it's stored with 64 bits instead, but let's just say 32 bits for now. And the question I have here for you is, how many bytes do you need to store each integer? Well, that's pretty simple.
So how many bytes? Then we need, if 1 byte is 8 bits, then in order to save an integer, we're gonna have to need 4 bytes.
Because you have 8 bits in each byte. So if you have 4 bytes, you can store 4 times 8 bits, which is 32 bits, which is just enough to store each integer. So how can we store an integer on memory? You might say, wait, why don't you just take 4 bytes, the 4 consecutive bytes right here, and then use that to represent an integer? And that's exactly what a real computer does. So in this particular case, when you have int a equals 1, 1 is first of all converted into 32 bits, zeros and ones, and those bits will be split into these 4 bytes, and then they're going to be stored right here on those 4 bytes. If you have one more integer, for example, int b equals 3 right after this line, that variable will be stored on those 4 bytes right after the first 4 bytes. So that's how integers are stored on memory, but actually the idea is going to be the same for things like decimals or characters. You might need a different number of bytes to store each different type of data, 2.3 or A or whatever, but the idea of using consecutive bytes to store each piece of data is exactly the same. Anyway, what if you wanted to store an array of integers instead of single integers? To see how that can be done, let's take a look at some more code in C here. And let's say, just like before, we have int a equals 1, then that integer a, or 1, will be stored, let's say, in these 4 bytes from 120 to 123. And let's say right after this line, we have this line, int sample array square brackets 3 equals 5, 3, and 20. This array will actually take 12 bytes right after the first 4 bytes, so that's from 124 to 135 right here. And we need 12 to be able to store 3 integers. So that's, of course, 3 times 4 equals 12 bytes. And the first number 5 will be stored in the first 4 bytes. So that's from 124 to 127 right here. And the second number 3 will be stored in the 4 bytes right after that, naturally. So that's from 128 to 131. And then 20 will, of course, will be stored in the last 4 bytes right here. Now, the question we asked ourselves earlier was, why can't we just add 2 more numbers, let's say 1 and 2, to the end of this sample array? You know, if you look at this model of memory, it looks like we'll be able to just allocate 8 more bytes over here and then use those 8 bytes to store these 2 integers. But actually, you can't do that. To explain why you can't just do that, why you can't just allocate more memory, allocate more bytes right after this array, I would actually need to explain a little bit more about how memory works exactly, but let me give you a more simplified argument here instead. The simplified argument here is that
Wait, is he saying
will be stored in the last 4 bytes right here. Now, the question we asked ourselves earlier was, why can't we just add 2 more numbers, let's say 1 and 2, to the end of this sample array? You know, if you look at this model of memory, it looks like we'll be able to just allocate 8 more bytes over here and then use those 8 bytes to store these.
So what he's saying, like, I know you guys understand this, but for myself, in C, when we're creating an array, we are allocating only 3, like, how do I say, 3 location, right, in memory. So only these values are stored here, and we cannot add more values to the end of the list. Why is that? Why it's the case? Let's understand.
2 integers. But actually, you can't do that. To explain why you can't just do that, why you can't just allocate more memory, allocate more bytes right after this array, I would actually need to explain a little bit more about how memory works exactly, but let me give you a more simplified argument here instead. The simplified argument here is that after this line, after allocating 12 bytes for this array, we don't know what's going to be right after that in this memory space. So for example, you might have this line int c equals 4 right after this line. In that case, this number 4 would be stored in these 4 bytes from 136 to 139. And when you store an array, you need a bunch of consecutive bytes. And that's basically why you won't be able to just add more bytes.
Well, I see what he meant now. He's saying that
To this array. And actually, if you wanted to still add 2 more,
he's saying that how do I draw? Can I draw here? Like why I can't draw? All right. So basically, we have an array, right? Let's just create like int array, which has the space of 3, right? Is equal to 3, 6, 4. Let's move this right here, and we're gonna need 12 bytes to store 3 integers. This is the first. Right, draw is T, right? Yeah. And this is second, and this is fourth. But we had an extra array space here, right? And an extra space before when we are in the memory. All right. Whoop whoop whoop. And an extra space here. My neck is really hurting now. We can extra space, but why can't we add new value to the end of the list? Because after this declaration, like thereof declaration, we may have a new variable declaration like int c, which is equal to 7. So, and the computer saves that, stores this variable, this integer, right after the array. So for the array to be array, we need consecutive byte of space, right? This is the case here.
Numbers to this array, what you would need to do is you would need to create an entirely new array, over here in memory, and you would need to make that array longer than the original array, let's say length 5.
Well, I think this is also the case why we cannot do that in Java as well. In Python, we could add, I have to research this through and why we can actually append new value in Python, yeah.
5 instead of length 3, and copy over these numbers one by one to the new array. And you would probably create this array dynamically, and this word dynamically is important, but if you don't know what it means exactly, don't worry about it for now. And then if you wanted to add even more numbers, let's say 3 more numbers to the new array that's longer than the original array, then you would actually need to create a new array again. It's actually what's used in practice often. So if you wanted to create sort of a resizable array, a kind of array, a kind of new array, you might say, that can accommodate as many elements as you want to put in there, this is one strategy for doing that. So for this, resizable array, you can initialize it as a small array. Let's say 10 elements. And then when you want to put in the 11th element, you can make a new array that can accommodate 20 items instead, and then copy over old items to the new one, and then keep going like that. 20 elements, 40 elements, and then length 80, and so on. And this is actually the essence of how many sort of resizable arrays work in different programming languages. So for example, in Python, you might see the Python list, and in Java, you might have used the array lists. They might not look like resizable arrays when you look at them or when you use them, but actually, if you look at the source code, if you sort of look inside the hood, that's how they are implemented. Okay, so this was actually a somewhat simplified explanation of these topics, arrays and memory, and you'll be able to actually start using them to start building more complex data structures that you're going to learn throughout this course, like hash tables and trees. And by the way, when I was doing some research for this video, I actually used this video's sponsor's website a lot, and it's called brilliant.org. So for my research, I was using this computer memory course. And the section I used the most is called Linear Memory Model, which is in the Introduction to Memory chapter. This linear memory model
All right. So, yeah, let's not. Let's ask a question. Why lists in Python are dynamic? I don't know, someone is calling me. Hello? Oh, den är sån. Nej, alltså. Idzie outro. They are named after the least abstract data type and not linked list. No, I'm not asking for why are they named like that. I'm asking for So an array is ambiguous term in Python and best not used. Most beginners use to refer to the list type, but are unaware that there's actually array type in the standard library as well. There's what? They are different. Let's see why they're different. So they're different. First, array holds one type. Lists can hold many types. Yeah, this is the first difference, because in Java, array, like, let me show you exactly what I mean here. Let's just go here, day 3, main.java. In Java, like, public single-army args. Let's move right here. All right. Well, in Java, when you create an array, like, how do I create new array? All right, Java is activating. Array list. I think in Java it would be like this. Right. What's the problem here? Alright, array list, package main, okay. Just I forgot Java, honestly. Anyways, this is a case like array list, new array. Like, this is just a demonstration for you, right? New array list. So we're gonna do this and string. We know that any value inside this new array will contain only strings, not any other type of data type. So yeah, my computer is kind of lagging. I understand that. Fine, I don't need that. Don't need that. Alright. So the first difference is that isn't clearly clear in Python, but if you take into consideration other languages such as C++ or Java, it becomes more obvious. For example, to create an array that stores integers in Java, you can do int array new int 10. Alright. This allocating, yeah, I was forgetting this word, allocate. Let me check if my stream is actually working or not. 네네 이만 접거리 어디만
Structures that you're gonna learn throughout this course, like hash tables and trees. And by the way, when I was doing some research for this video, I actually used this video's sponsor's website a lot, and it's called Brilliant.org. So for my
anyways. So yeah, allocating the necessary memory to hold 10 integers in array. So for my safety and then such, let's just quit Visual Studio, alright, for now, and just use, you see, activity monitor, Firefox using 1 gigabyte. It's crazy. I have to upgrade my laptop, otherwise I can't have normal 10 integers in the array, but if you can only but you can only store integers. If for example you tried that a string to this array, it would give you an error. While this thing while the single type idea seems limiting, it can be generalized as well. Suppose a custom class person is created and you want to make an array of person type that stores person objects. You can do the just easily person people new person 10. Yeah, easy. It could be a person object that has fields, attributes of varying data type, string, int, another array, etc. Each collection of the attributes which make up a person can be stored in this array as long as the collection itself is an instance of the person object or is a subclass of person. Whereas in a list in Python, this isn't necessarily true. It is the case that a list itself is a single data type. However, it can store multiple data types and those data types are individualized. What does that mean, individualized? Well, for example, making a list that has strings, integers, and floats in it, like data, hello, 23, frank, float, integer, float, or decimal, and this is string. Arrays have fixed size. Lists can change dynamically. Exactly. This is what we have been learning in this stream, right? Lists can be dynamic, but arrays are static. We cannot change them. We cannot add new value to them. So, good. Yeah, and the second difference is also not as obvious, since in Python we can just use a list if you if you feel like would like things to change in place, right? We can just go ahead and just add a new value. But with array we cannot. The space that's allocated for an array is fixed and known ahead of time. If you try to make a change such as adding an element onto the end of it, you have the possibility of overrunning the array, going over the space that has been allocated for just the array. This is a hard bug to track down and can cause security issues such as buffer overflow. Exactly. The problem of overflow is that the data stored inside an array is stored contiguously next to each other. Yep, this is it. Because data stored inside the array as consequently next to each other in memory. So imagine a row window. If you access the science field today, for example, that may be illustrated. And to make a change like adding the element of the end, you must allocate another array with the additional space necessary, then copy the elements for the array. Old, new 10, 11, and new int 11, 1 in for all die is equal to. With the list, we don't have to worry about as much since it changes dynamically. Automatically, we can update this. But still, I don't understand, man. I don't understand how the memory works under the hood. Okay, let's just ask ChatGPT. How are data stored in lists in Python? Mutable ordered mutable collections and uses of multiple items in a single array. Internally, the data is stored in relational combination of array-like structures and pointers. Okay, Alright, why it's so freaking slow? I think I have to log in. Let's log in now. Alright, I think I have to take a break. Oh, first let me just um, use Google to log in. Alright, let's allow. Why are lists in Python are dynamic, and how do they work under the hood? Arrays are arrays are different when we initially create an array. We allocate a memory with specific storage space. Example here, array int 3, right? Or what was it like this? R. Was it R? Yeah, int array new int. Yeah. Int array new int. How are bytes stored in Python? Why we are able to add new value onto the end of the list? Let's see. Great question. This is actually the most fascinating thing about Python list. In Java, when you create an array, like the compiler allocates a fixed block of memory large enough for 10 integers. You can't add more than 10 items without reallocating a whole new array. Arrays are homogeneous. What the frick does that mean? Every element must be of the same type, right? And Python list is not fixed size array. It's dynamic. It can grow or shrink as needed. Exactly. I'm just repeating myself. It's needed for me to learn, to like get accustomed to speaking in English in technical terms. That's why I'm just freaking repeating myself every time. And Python list is not a fixed size. And it said, okay, how Python lists work under the hood? Python list is implemented in C Python as dynamic array. Use reference pointer. Alright, and I understand. Let's take a break. or maybe just live as it is. I'm gonna come back in like 15 minutes or so. Goodbye.
qiynading. Ё-моё! Тапшкиз bormen sizda.
Oyog'i zerikmaydi. Mani topishgan yuvar turib. Eskiga просто magazin chiqishadi. Bunaqa.
Hamma akasidan qolsa hammani eski. Hali ko'nglingiz yo'qmi?
Nima derdi ya? Intriga dermidi nima? Sensatsiya.
Sensatsiya. Bo'ldi bular.
Bunaqa sensatsiyasidan kutmadim lekin. Dodagami deyman ha bari. Shunga qolganmi deyman.
Voy bil. Ammo o'ziga. Nimaga ham tushsak.
Achingizda deyman.
Ha, borlikda ya.
Qulog'im mana shunday qilib chiqaman.
Erisiz deb qo'yaman. Kenyapti nafas.
Zashitni achchiqdan ko'rdim, uni endi 100 ming eganda oddiylar ko'rdi.
Men jakob yubormadim. tezroq shug'ullanib tezroq bitta yuvinib telefon olib chiqmay ketdi.
Prokurasan o'zing boshqani, prokurasan g'alati ishlar. Bilmasligini bitirib boraman.
We are back. We're back in the business, man. Let's drink up some water. We're back in the business. All right, let's continue. All right, yeah, we had some cool understanding of what our arrays are and how we can do that. So first, now let's move to neat code and solve a problem first. Then we're gonna see what happens next. All right. So we're gonna sign in again. All right, GitHub. Do I have GitHub account connected to this? I guess no. Why it's light screen here? Two-factor authorization. Of course, man. How is my string going?